is our topic. Then, this is our proposal. The 3D coordinate calculating in the Laparoscopic training system is our goal. And using the FPGA to improve our system is how we implement this system. Then using the MATLAB to reduce our developing time is how we try to do. And using the FIL, FPGA in the loop technology to verify system in short time is the other helping. Why we need the FPGA? Because the function of our training system need to do a lot of things. That's why it need cost a lot of loading. Especially is one, you need to processing two images in the same time, finding the mark and finding the location of our instrument. And so therefore, we want to reduce this part in our system. And why we use the MATLAB? Because we think if we use the Verilog to develop our system, maybe take a long time. It is not enough for us to join this competition. That's why we use MATLAB to, and especially the Shiu Simulink in MATLAB to help us. According to the MATLAB, they say using this system, it can shorter the investment time about 50%, and reduce the prototype development about also about 50%. Next, this part is what is FPGA in the loop. In the past, if we want to develop in the FPGA system, we need to use the quantum system, and we write the Verilog code and simulation in the model scene, and synthesis in the quantum, then go back to model scene. In the MATLAB, they do not need to do these things. We just develop our algorithm. Then the whole system can connect with the quantum to synthesis, and sending the data to the FPGA, and in the same time getting the data from the FPGA to verify our result. Okay. That's why we want to try this new method in this project. Okay, this is our architecture. First, we use the instrument is here, and using the 3D camera. There are two cameras in our system. Through the USB input to the MATLAB, then the MATLAB will using the internet, sending data to the DE2. Then we starting to calculating our algorithm. First is RGB to HSV, then finding the mark. These two parts, we want to reduce the calculating time, so we use a pipeline in this part. And also there are two image inputs, so we use the parallel calculating in this part. Then this part, the method cannot, some block in the Simulink can generate the HDL code directly, but the direction and the erosion part cannot do this. The simulations give you this function, but it's just for the software simulate. If you want download into the FPGA, it just not working. That's why this part we do it in ourselves. Use our way to do it. Then we finding our we got the then we can start finding the 2D coordination data. Because we have two cameras and two instruments, so we have four 3D coordination data. Then we will use those data to find out these two instruments 3D coordination. Then send it back to MATLAB to verify our system. Okay. This is the traditional method, how we use how we transfer the RGB to HSV. But the different parts, normally in the MATLAB, we are using the float point to calculating this data. But in the FPGA, it's very difficult to implement for floating data. That's why we use a fixed point. But the fixed point has the other problem is it's not integer data. That's why we shift the data and for this degree to integer domain. Okay, how we use the pipeline to accurate our system. This part is RGB to HSV. Every pixel coming to our data is pixel by pixel. Therefore, we can find out the HSV. Then we can make sure if this point is our color, yes or no. If yes, we can send it back. So we can do it in the same time. Convert one pixel and then calculate and then compare this data. And then the next pointer can convert here, and previous pointer can find out here. Okay, next. And due to we have two cameras, so we need to have two converting parts in our system. So we do it in the same time. Okay. This part is dilation and erosion. But this part we are this is the simulated block, but we have our method to redefine this. And then my partner will show everybody how he did this part, and maybe he will speak in Chinese. Okay.
我们这次的输入主要是一个点一个点输入，可是，在我们的膨胀或者是侵蚀的过程之中，我们必须要有通常都是用个3×3的 mask。那如何去克服这个问题呢 ？MATLAB 它主要在我们这次的图形主要是320×340，它是一条一条直的在扫。那我们主要是用那个 MATLAB 里面的一个延迟的功能，它可以延迟第一个点，然后过240个点之后，又跑到第二行第一点，然后用同样步骤，我们就可以把第一行，也就是同一个 row 的3个点都抓到。那从这边就输出一个3×1的矩阵，对。那再用同样方法呢，3个，再把它变成一个 matrix 输出，就是变成一个3×3的矩阵。对，我们就是用这个方法，就是把一个点输入的方式去想办法用这一些延迟的方法，最后再组成一个3×3的遮罩，以便进行我们之后的膨胀以及收缩的运算。对。那我的解释就到这边。
Okay, this is our result. This picture is before doing this erosion and dilation. And after this, we can, because in our system, the color, the light is very balanced. That's why you can see probably it's not different. But actually, when we calculating the next page. Okay. Probably you see this point when we run out this image, you can find there are a little bit pixel is there. It will confuse our calculating the middle point of our system. Now that's why we still need this algorithm. In this stage, we are not finished the whole system because all the algorithm we already finished, but the HDL coding also has problem because the 2D coordinating part, the middle point of our graphic, still we need to find the best way to present in the simulation. So this part is still developing. The first study, we want to improve our system. In the next, we will try to finish our whole system, and because the MATLAB just help us to develop the algorithm and verify our system. Therefore, in the future, the MATLAB will take out. This system will become a standalone system. Then we will replace the USB webcam to a camera module because we can get the data from the Eugene's camera module directly. We do not need the USB cable, but in the future. I think this part will improve the speed more effective. The other thing is, because we reduce the calculation of our PC system, so therefore we do not need the PC again. Maybe we can try to develop our system in the Linux or Android base to improve the portability and the convenience and the cost down. Thank you for your lesson.